This is the video lesson for 4.1, Graphing Quadratic Functions. As you can see from the completed notes, which you can follow along with using the blank notes found on Canvas, a function of the form y or f of x equals ax squared plus bx plus c is called a quadratic function. The graph of a quadratic function is called a parabola, and that's fairly significant because as we move into chapter 4, we're going to be looking at quadratic functions. So this is the standard form of a quadratic, and of course it graphs as a parabola. A parabola is a U-shaped graph that opens either up or down. It's not a perfect U because as it opens, it gets wider and wider. So you can see our standard form. And the first thing I will point out, in standard form, if you put in 0 for x, the first two terms will disappear because 0 squared is 0 times a would be 0 plus 0 times b would be 0. So when the input is 0, which is where you're really finding the y-intercept, it will always be the value of c in standard form. And that's an important point to use when graphing. As far as the other values in the equation, a tells us a lot. It tells us about the direction of opening, and if it's a positive value greater than 0, the parabola is always going to open up. While if a is less than 0, the parabola will open down. This is similar to absolute value graphs in that a tells you the direction of opening. The x-coordinate of the vertex can be found using the value of b and a and taking the opposite of b over 2 times a. So this is really what you're going to use to find the x-coordinate of your vertex. How you find the y-coordinate is by plugging back into the actual function in the equation right here to get you the y-coordinate. And finding the vertex is one of the most important things you'll have to do. The axis of symmetry, which I abbreviate AOS, is the vertical line that will pass through the vertex. So its equation right here is x equals the opposite of b over 2 times a. And you can see that line is called the axis of symmetry because the parabola will be symmetric on either side of this vertical line. And then the y-coordinate of the vertex is either called the maximum or minimum value of the function, depending on whether the parabola opens up or down. So let's see how this works. And I have 3 examples. The first example you can see is y equals x squared. This is often referred to as the parent quadratic function. And when we take a look at the standard form, we need to understand it's really y equals x squared plus 0x plus 0. And the coefficient of that first term is really just the value 1. So even though we do not see that coefficient, that's its implied value. So as we identify the values of a, b, and c, a would be 1, b would be 0, and c would be 0. The first thing I need to recognize, if a is 1, it's positive, and my parabola is going to open up. And if a parabola opens up, if you think about it, the vertex is a low point on the graph, so we have what's called a minimum. And that minimum value is the y-coordinate of the vertex, or 0. And I'll point that out when we see the graph. So to find the x-coordinate, we're taking the opposite of b, which would be still 0, over 2 times a, 2 times 1, and 0 over 2 is going to be 0. And then you can see I already have the completed chart here with the values. And what I do is I take 2 values on either side of my vertex. So I know my vertex is the origin because if I plug in 0 for x, y is 0. And then I test x values on either side of my vertex. So to the right of 0, I tested +1 and +2, and to the left, -1 and -2. And of course, if I input those x values for y equals x squared, I get y values of 4 and 1 as shown in the table. And what I want to do is graph those. So I'm going to come up here and we're going to see this. So I am going to graph my vertex at the origin. And then I'm going to graph +1, 1 and -1, 1. And then I'm going to graph 2, 4 and -2, 4. And then I will draw through these points. And when I draw through, I get my parabola. As far as the axis of symmetry, it is the x-axis. Now, normally I would draw that as a dashed line, and the axis of symmetry here is x equals 0, because that's the equation for the y-axis, and that's what we got up above. We can see the y-intercept of our graph is indeed c, or 0, which is the ordered pair 0, 0. And as far as domain and range, we can see this above here. The domain would be all reals, and the range would be y greater than or equal to 0, since the entire parabola starts at its vertex, where y is 0, and opens up, which includes all y values above 0. That's what we call the parent graph. Now let's look at a second equation. You can see y equals 2x squared minus 8x plus 6. So in this equation up here, you can see the values of a, b, and c are +2, -8, and +6. Again, our parabola opens up because a is positive, greater than 0. And when it opens up, of course, the vertex is a low point, like our last graph. And when we have a low point, we know we have a minimum. And as I said, the minimum value is the y-coordinate of our vertex. So we have a minimum in number 1, which would be 0. In our case, we need to go ahead and find our vertex. So we've done that here for you. And we have taken the opposite of b, so the opposite of -8 is 8, over 2 times a, 2 times 2 is 4, so that means the x-coordinate of our vertex is 2, and if we plug that in for y, we can do that very easily, and I'll show you that here. I'll show you this down here a little. So y equals 2 times 2 squared plus 8 times 2 plus 6. And that's minus, so let me get that corrected, minus 8 times 2 plus 6. So you have to square first. 2 squared is 4, times 2 is 8, minus 16 plus 6. It looks like when we simplify that, that becomes -2, which our table of values here shows you our y values for the given x values. So let's see if we can graph this, and I'm going to move this up just slightly so I can get to the graph. So I want to graph the vertex at 2, -2. That's be right here. 1, 0, and 3, 0 are points I found by plugging in the values on either side of the vertex. So since my vertex here was at 2, -2, the two values to the right of 2 were 3 and 4, and the two values to the left, 1 and 0. We prefer to use integers when we do this. And then we plug in to the function like I did right here to find the y-coordinate, and you can see the values I got for y in our table. And then we have 0, 6, 2, 4, 6, which means symmetry on the other side. So if I draw through, my parabola is opening like that. As far as my axis of symmetry, that's got to be that vertical line passing through our vertex, and that is x equal 2. And as far as max and min, because it opens up, we have a minimum, and our minimum value is -2. That's the y-coordinate of our vertex. If you look up above, we can see the domain and range. The domain is all reals again because that parabola opens up and gets wider and wider and would consist of all real values. But the range would start at the lowest y, which is -2, and go up to positive infinity. So it's not really that bad. Let's look down to number 3. This time we have a quadratic function where a is negative. A is -1, b is -10, and c is -24. Because a is negative, our parabola will open down, and if a parabola opens down, our vertex will be a high point. To find our vertex, we take the opposite of b, which would be 10, over 2 times a. 2 times -1 is -2. So that means the x-coordinate of our vertex is -5. And then again, we can find the y-coordinate if we want by plugging into our function. That would be like this, the opposite of a -5 squared minus 10 times -5 minus 24. And if I simplify that, that'd be, you square the -5, that's 25, but the opposite means -25 plus 50 minus 24. So basically, this ends up giving us a +1. And that's what you do for all points. So you complete your table of values here, right here, testing 2 values on either side of that vertex. We set our vertex as -5, 1. It's the ordered pair. And then 2 values to the right of -5 on the number line are -4 and -3. To the left, -6 and 7. And when I plugged in, I got these values. So let's move down and take a look at our graph here. So here is our graph. Our vertex is at -5, 1, and I've graphed the points on either side. And since it opens down, our maximum value is 1. Our domain would be all reals, and our range y is less than or equal to 1. I don't see my y-intercept on this graph, but when I look back up here, my y-intercept can be found right here. It's really the ordered pair 0, -24. I don't have to graph it to recognize that is my y-intercept. So maximum and minimum values occur at the vertex. If you're asked just to find those, you just need to find the vertex coordinates and recognize whether the parabola opens up or down. You don't have to graph it to find that. So when you look at your homework, you're doing 13 to 19 odd, 23, and then 27 to 31 odd. In the first bunch, you are graphing, and they ask you to find all the pieces like I've just done. But in the last pieces, they ask you to determine whether the quadratic has a maximum or minimum value and what it is. So the value of A tells you whether it opens up or down, and consequently whether you have a minimum or a maximum. And then you have to find your vertex because the maximum or minimum value is the y-coordinate of your vertex. But on those last problems, you don't have to graph. So you can see your homework. It's right here. And we will be testing tomorrow and then block day this week, and we'll go from there. And period 5, you will have a lunch. All right, have a good one.